So we are going to look at the linear equations of motion. We make use of them to solve every problems on motion in a linear form. We have basically 4 equations for our linear equations of motion. I'm going to take them one after the other, and we are going to look at what each of the letters stands for. The first, I'm going to take 1. V is equal to U plus AT. The next I'm going to take is X is equal to half open bracket V plus U bracket close T. Then we are going to look at a third. V squared is equal to what? U squared plus 2AX. And the last we are going to take here, X is equal to UT plus what? Half AT squared. Where our V is equal to what? Our final velocity. Our U is equal to initial velocity. Our A is equal to acceleration. Our T is equal to time. And our X is equal to distance. It can also stand for height. And it can also stand for depth. When we are considering motion under gravity, our A, which is what? Acceleration, can be also changed to what? A G, where our G is called gravitational acceleration. Our G can be used as what? Gravitational acceleration. And the value we normally use, 10 meters per second square. This value is a what? It's a constant value. Normally make use of when we are considering objects that are moving under gravity in free fall. So, if we are considering motions under gravity in free fall, in straight line, this same equation can also be used. But the only thing that will be changing in these equations will now be what? The symbol G there. So under gravity, under free fall, we call it free fall. Under free fall, we have our equations as this. V is equal to what? U plus GT. The other one, we have our equation as this. V squared is equal to what? U squared plus 2GX. Then the last here, we have our X is equal to what? UT plus what? Half GT squared. So these formulas are the same as these formulas. But the only difference is when we are working with objects that are falling freely under gravity on a straight line. For example, a body that is thrown vertically upwards, moving on a straight line, or a body that is dropped from a height, falling on a straight line under gravity, then our A is now changed to what? To a G. That is what? Gravity. You don't need to cram most of this equation, but you just need to do what? Know them. How do we know them? Basically, it is simple. Deducing. Let's see, deducing the linear equations. Deducing the linear equations of what? Motion. Every definition definitions that we have taken so far, they generate the equations that we have been using right now. It is not a rocket science for you to know this equation, but just know the definitions. For example, let's look at the first equation, V equal to U plus AT. How do we come about this equation? Is from the definition of what acceleration is. What is acceleration? We say that acceleration is the rate of change of velocity with respect to time. So we simply say what? Acceleration A is equal to velocity change. Velocity change is given as what? V minus U all over what? All over time. This is how this formula come about. What do we do? Make V your subject. If you want to make V subject from this formula, say make V the subject formula. Now, from this expression of acceleration, we want to make our V subject. So to make our V subject, first we are going to do what? Cross multiply that. And what are we going to get there? V minus U is equal to what? AT. So when our minus U crosses to the other side of the equation, it now becomes what? Plus. So we now have V is equal to what? U plus what? AT. This is how the first equation comes about. That V is equal to U plus AT. As simple as just knowing the definition and you've gotten what? The first equation. Let's look at the other equation we have there. It's simple. It's just derived from the expression of our average velocity. What do we say is average velocity? Let's look at that. Average velocity. Average velocity. We said average velocity is given as what? V plus U all over 2. And we also say that average velocity is the same thing as what? Distance. And our distance is x all over what? Time. So it is this equation now that gives us our next value. Now let's look at this. We are simply saying that x over t is equal to what? V plus U all over 2. What is V plus U all over 2? This can also be expressed as what? 1 all over 2, open bracket, V plus U. So we make our x subject. If we want to make our x subject here, make x what? Subject what? Formula. If we want to make x subject formula, x now becomes what? Our t will cross to the other side. 1 all over 2, open bracket, V plus U, bracket t. So this gives us what? The second formula that we have there. Equation 2. Now, if we want to get the third formula, if we want to get this formula, it is also taken from this first and second formula that we have got. What do you do? From your first formula here, make your t the subject. To derive our third equation, we say what? Make t subject from our equation 1 and substitute in equation 2. That is just basically what we are going to do. Make what? T the subject formula from this equation 1. Then substitute it into equation 2. We are going to make t the subject from this. So what do we have? T will be equal to what? V minus U all over what? A. This is t from equation 1. T will be equal to what? V minus U all over A. Because when U move back, we have this. We have this. Going backward, we are going to have this. So this is our t. So we are going to substitute this value now into what? The next equation, the second equation. And what will that be? In our second equation, we say what? In x is equal to what? Half bracket v plus u bracket t. Wherever you are seeing t there, put your v minus u all over a in the place of t there. And that will give us what? X is equal to what? Half open bracket v plus u bracket close. T is now what? V minus u all over a bracket close. So this basically is what? What do we have here now? We can simply write this as what? Our a is dividing. It can comes out. X is equal to what? Half 2a open bracket what? V plus u open bracket v minus u. And this is what we have. So we can cross multiply our 2a down to meet the x here. And that gives us what? 2ax is equal to v plus u open bracket what? V minus u. We are going to expand this bracket now by doing what? V times v will give us what? V squared. V times minus u will give us what? Minus uv. U times v will give us what? Plus uv. And u times minus u will give us what? Minus u squared. This is what we have. You can see that this is minus uv plus uv. They will cancel out. So we now have what? V squared minus u squared. And what do we have? If we want to make our v squared subject, so making v squared subject, making our v squared the subject formula, what do we have? Our minus u squared will cross and come to this other side. So we now have what? U squared plus what? 2ax is equal to what? V squared. This gives us what? The third equation. Similar thing is done to get what? The fourth equation. We are going to look at using the equations of motion in solving linear problems. Now we are going to look at problems on linear equation of motion. Now let's look at the first one here. Number one, a car has a velocity of 72 kilometers per hour. Say, how far does it travel in half minutes? Now let's look at this solution. When we want to solve problems, we must make sure that the units for each of the quantity given to us is in the standard unit. The unit is in the standard unit. Now what do we have here? A car has a velocity of 72 kilometers per hour. So our velocity here is what? 72 kilometers per hour. They say, how far does it travel in half minute? What's the time given to us here? Time is what? Half minute. And they want to know how far it travels. How far it travels means the distance that has been covered. So we want to look for what? Distance. The unit here is minutes, and the unit here is what? Kilometer per hour. We cannot use them together. It's either we change all of them to the standard, which is meter per second, and change this one also to second. Or better still, we can also change this minutes to hour, so that we can express our distance in kilometer per hour. So let's change our half minutes to hour. We want to convert our half minute to hour. If we are converting our time to hour, what do we have? We have 60 minutes is equal to what? 1 hour. So what will be our half minutes? Half minute will now be equal to what? 1 all over 60 times, what do we have? Half. You get that now? 60 minutes is equal to 1 hour. So half minutes will now be equal to what? 1 over 60 times what? Half. And this will give us what? 1 all over what? 120 hours. So we have converted the time to hour. So now we can solve. What is our distance? From our equation, velocity is equal to what? Distance all over what? Time. We can get our distance by writing distance is equal to what? Velocity times what? Time. So what's our velocity? Our velocity is what? 72 kilometers per hour. And our time is what? 1 all over 120. 1 all over 120. So this will give us what? Let's divide. What can divide here? What can divide? 6 can divide. Let's divide by 6. 6 divided 7, we have what? 1. Remaining 1. Carry the 1 to 2 becomes 12. And 6 into 12 will give us what? 2. And 6 divided 120 here gives us what? 6 into 12, we have 2 and 20. What can divide here? 4 can also divide. This will give us what? 4 divided is 3 all over 4 divided 20. What do we have? 5. So our distance is equal to 3 over 5 what? Kilometers. This is the value of our distance, 3 over 5 kilometers. I'm going to look at question number 1 again. This time, I will be changing the units to the standard. So question number 1, solution 1. Our velocity, which is equal to what? 72 kilometers per hour. Let's convert 72 kilometers per hour to meter per second. If we are converting this to meter per second, what do we have? We are going to have 72 times, that will give us 1,000 all over 3,600. When we convert this now, what are we going to get? 0, 0, 0, 0. And we now have what? This will give us what? 720 over 36. And this gives us what? 20 meters per second. Because 36 will divide this will give you what? 2. So we have 20 meters per second. Now let's look at our time. Our time is given to us as what? Half minutes. Half minutes, when we convert half minutes to second, it becomes what? 30 what? Seconds. So now let's look at the distance covered. Distance. So our distance will be given as what? Velocity times what? Time. Velocity times time. Now, our values here now, they are all in our standard unit of meters and seconds. So, what do we have? Velocity 20 times our time is what? 30. And this will give us what? Velocity times time. That will give us what? 2 times 3 is what? 6. And we have what? 600 what? Meters. 600 meters is the same thing as 3 over 5 kilometers. 600 meters is the same as 3 over 5 what? Kilometers, which is equal to our what? Distance that was calculated. So any method that is easy for you, you use it.